My specialty is in stochastic mixed integer programming. So what that means is decision making under uncertainty, where the decisions involve discrete choices like on, off. So imagine a data center with 100 computers, each of which you need to decide whether to keep it on or off. Now that makes 2 to the power 100 decisions. That's not 1 million decisions, 1 billion decisions. That's called 1 nonillion decisions. So that's 1 with 36 zeros after 30 zeros afterwards. So that's a lot of things to consider to make your best choice. What my research enables you to do in situations like this is to make the best choice possible with very low computational effort. So it involves developing theory, it involves developing algorithms, efficient algorithms, and it really, in the end, needs to solve an important real-world problem. So some of the applications I'm working on include supply chain management, disaster preparedness, homeland security, and most recently social networks. What I like most about my research is it's a nice balance of fundamentals and computations and practice. What I develop is general methodology, so it's widely applicable to many different decision-making environments and problems in industry, government, or nonprofit organizations. So I like its versatility. I like its I like that it's powerful. It's able to solve very complex problems in a few seconds instead of many hours. My research helps decision making under situations that involve low likelihood events with dire consequences. So it helps us prepare better for the next terrorist attack and upcoming disaster, or just simply make better financial decisions before a financial crisis hits. So I think it has potential to have wide impact both in government and industry. So I think that's why it's powerful. My research is sponsored primarily by National Science Foundation, and I like to work on these research projects with graduate students. I advise several PhD students in this research, and I enjoy working with them and mentoring them and preparing them for a career in research. I also enjoy incorporating my research into my teaching, my classes, both at the graduate and undergraduate levels. My research is in stochastic mixed integer programming. So what that means is, stochastic means we're making decisions under uncertainty. And mixed integer means some of our decisions are discrete or on-off type binary decisions. So that makes the decision space very large, very hard to explore. And my research comes in and makes this complex decision-making problem much easier to solve. So a few seconds instead of hours of computing. I like the fact that it is versatile. It's applicable to many practical areas. So in the past, I worked on problems in supply chain management, but more recently, I've been looking at problems in disaster management, in homeland security budget allocation, and very recently, I've been looking at social networks applications. So picking as an example the social network application, we are given a social network like Facebook, Google+, and Twitter, and we're trying to find out individuals who are highly influential so that we can market a product and it goes viral. So this is a decision-making problem under uncertainty because we don't fully know how the influence structure works. So we're trying to we have a limited budget in allocating how to market to these individuals, and we'd like to have the most widest impact. In another application, in disaster management, we are looking at a pre-disaster response planning. So we're trying to decide where to locate our resources, so emergency medical supplies, water, food, so that if a disaster hits, then we will be able to reach as many people as possible, and we would like to make this distribution equitable, so we can access a diverse population. So the decisions again involve these on-off type decisions, whether to locate a facility in a certain arena or a hospital, and also the quantities of supply to produce in each area. And the uncertainty comes from the fact that we don't know when the disaster will hit, how hard it will hit, and what the demand for these supplies will be. I believe my research will help us prepare better for an upcoming financial crisis, disaster, both man-made or natural. My research is mostly funded by National Science Foundation, and with this research I'm able to advise several PhD students in their research, prepare them and mentor them for a career in academia or research or industry. I like working with the students. I enjoy helping them develop their research abilities. In addition, I like to incorporate this research, the real-world example and the high impact of my research into my classes, both graduate and undergraduate level.